Okay, so now we move to lecture 2, part 2. We discuss about particles, kinematics, okay, also for the motion along a straight line. Okay. So for we have the learning outcomes. That means when we finish lecture 2, part 2, we will get some knowledge here. Okay. Yeah. So we already discussed this one. So now we will analyze some objects. Okay. With the motion of a constant acceleration, including free falling objects, okay, free falling problems. Okay, so lecture 2, part 2, we will focus on this one. Okay, yeah. Of course, before we consider the object with constant acceleration, you need to understand what the acceleration is. Okay, so similar to velocity, we have instantaneous acceleration and average acceleration. Okay. So if we have displacement x, okay, we take the first derivative of x with respect to time, you get vx, and then we take the second derivatives, right? You get axa d square x over dt square. Okay, we take the second derivatives of x with respect to time, you can get acceleration. And we have the average acceleration here. Okay, ax average. Okay, ax average, and ax average is delta vx over delta t. Okay, so we get vxf minus vxi over tf minus ti. So of course tf is final times, right? Ti is initial times. Okay, this is initial velocities, right? Velocities. And Vxf means final velocity. Okay. Why we have x here? Because we are considering one direction. Okay, straight direction. So x means a strip. X means x-axis direction. Okay. Yep. And of course, every student knows the units of acceleration is meter per square second. Okay. So for considering figure A, we have x-axis direction. Okay. At the ti, you get vxi. At the tf, you get vxf. Okay. So this is graphical representation. Okay, so now we think about we use xy coordinate to indicate the motion of the object. Okay, so t means x-axis is for t, and y-axis is for vx. Okay, for vx. Ti, vxi, tf, vxf. Okay, and we have the curve like this. Okay, yeah. Of course, if we consider the red curve, this is a non-linear curve, right? Yeah. And we have the blue curve for a linear curve. And so of course, if Vx is linear, that means Ix is a constant. Ix is a constant. So if Vx is non-linear, Ix may be linear or not. Okay, it depends. So if we have a non-linear curve and then we have many small time interval, okay, very small time interval. So now non-linear curve becomes linear. Okay, if we shorten the time interval. Is it clear? Okay. And the slope of Vx, the slope of velocities will be the acceleration, okay, the instantaneous acceleration. Okay. Yeah. So if we would like to calculate the instantaneous acceleration, we need to calculate the slope of Vx, the slope of the velocity. Okay, or we can calculate the instantaneous acceleration by this one. What is it? This is the first derivative of Vx with respect to times. Okay, or this one is slope of Vx. Okay. Otherwise, if we calculate the second derivative of x with respect to dt squared with respect to times, we also get ix. Okay, it depends on the questions. They give us the function of x or the function of vx. Okay, or we can calculate ax by taking limits of this ratio. Of course, delta t is approaching to approaching to 0. Okay. Now we have the questions. So AX is positive or negative. Okay. Similar to VX. Okay. Sometimes VX is positive. Okay. Sometimes VX is negative. And now we have AX. Okay. Yeah. Of course, we just consider four quadrants, right? The first quadrant, the second quadrant, the third quadrant, and the last quadrant. Okay. Yeah, this is times. Okay. This is times, and this is AX. So if the vector AX like this, you get positive, right? And if the vector AX like this, you get a negative. Okay. So it depends on which quadrant contains vector AX. Okay. Yeah. Or we can say if the slope is positive, Ix is, if the slope of velocity is positive, Ix is positive. Similarly, if the slope is negative, the slope of velocity is negative, Ix is negative. Okay. Yeah. Like this. You know, this is Vx. And if we draw this slope, you get this one, right? Slope, 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 right? Okay. So on slope here will be at the first quadrant. So AX is positive. AX is positive. Okay. So here, you know, the slope of the velocities like this, like this, like this, like this. Okay. So all slope here R belong to the last quadrant. Okay. So AX will be negative. Do you understand? Yeah. Of course, if Vx is linear, Ax will be constant. But now we don't know because it's a very small figure. So you just draw the curve like this. Okay. Yeah. But now you can understand, okay, which case Ax is positive and which case Ax is negative. Okay. It depends on first quadrant and the last quadrant. I also explained to you why we don't consider here because the times normally is positive. Okay, come from 0 to positive infinite. Do you understand? Any questions? Hot boys, any questions? Rich kids, any questions? Yeah, question please. From here to here. Yeah, as mentioned before, because we don't know for exactly is Vx is linear or non-linear. So here we just draw the curve non-linear. But if we have bigger, clear figures, and if Vx is linear, so Ax will be constant. Okay. So now Vx is non-linear, right? Vx is non-linear, so Ax may be non-linear or linear. We don't know. It depends on the power of times. So if we have Vxa t to the power of 3 plus t to the power of 2 plus t, something like that. So that means Ax will have 3t squared plus t. This is also non-linear. But if we have Vxa t squared plus t, something like that, and Axa t, you get linear. Okay, so we don't know what is the function of Vx. Okay, we just say Vx is non-linear, so Ax may be non-linear or linear. Okay, so that is the reason we have the general curve here. Can you get my point? Yeah, good. Any other questions so far? Okay. Next. Very easy. Okay, because this is the big values of velocity, right? This is the big. So at the big, that means Vx is constant. Okay, we only have one big values as time tb. Okay, so Vx is constant, so Ax is 0. Okay, you get it? Okay, yeah. Average acceleration. Okay, average acceleration. Of course, we know, right? Average acceleration is delta Vx over delta t, and this is instantaneous velocities. Sorry, instantaneous acceleration. Okay, yeah, yeah. We can calculate instantaneous acceleration by taking the second derivatives, right, of the position x with respect to time. Okay. You have 3 minutes. Okay, try to understand the relationship between x and vs, or vx and ix. Okay, yeah. And any observation from you? Okay, from this slide. Yeah, try to think about what can you observe from this slide. Okay, so first of all, we consider Vx, right? So Vx, we have some linear region, some constant. Okay, so you can predict the function of x. X must be a quadratic equation, right? So x, and if x is a quadratic equation, when we take the first derivative of x with respect to time, you guess Vx is linear. Okay, yeah. Or here, if here, from this region to this region, this one like linears, so Vx is constant. Okay, yeah. So yes, here from 0 to ti, you get this slope. So I mean the velocity will be increased gradually because the slope is higher and higher. Okay, so you get here is Vx, right? And from here to here, x is linear, so Vx is constant. And this one is, this one is non-linear like this, okay? Yeah, like this, okay? So Vx reduce gradually, and when we get here, Vx is 0 because this is the peak of position curve. Okay, and here, here the slope will be at the last quadrant, right? At the last quadrant, right? Here, right? So Vx will be negative. Okay, negative. And when you get here, x is constant, so Vx will be 0. Okay, so according to x, you can get Vx. And of course, okay, based on Vx curve, you can get Ix. Okay, so here this is positive velocity, so Ix is constant and positive. Okay, and here this is constant 0, and this one, look. Okay, so if here is Ix, right? T Ix, this one is the first quadrant, right? This one is last quadrant, so Ix will be negative. Okay, yeah, last quadrant, and then here first quadrant again, and Ix is positive. Do you understand? Yeah. ECE in Tech 2024, they have a final exam like this. Okay, yeah. And I also explained this slide in class, but I don't know some students. They didn't answer these questions. Okay, I gave them the curve of x, and I asked them to draw Vx and Ix, and give some explanation to me. Okay, but they cannot do that. Okay. Any questions so far? Questions? Loudly, please. Of course, yeah. From Vx to Ix, we don't need to estimate the function. But the problem is from x to Vx. Sure. You don't know x, right? Because Ix is the slope of Vx. Ix is the slope of Vx. Okay. So over here, the slope is constant. The slope of the slope of Vx is constant, right? This is the slope. So if I consider this boy, I guess I get the slope, the slope, the slope constant and the same direction. Okay, so x is constant. Or you just consider here. So if Vx is linear, that means Vx is Ax plus B. This is time t, right? So It plus B. This is linear curve, right? So when we calculate Ax, so Ax is a derivative of Vx with respect to times. So you can get A, so constant. Yeah. So mathematically, you can you can consider this equation. Otherwise, you just draw the slope, right? Vx is linear, so slope is always in the same directions, right? The same direction and the same magnitude. Do you understand? Yeah. Okay, good. Yeah, I hope you enjoy it. Okay, so for example, okay, so for you have 3 minutes trying to understand how to get these answers. If you don't have any questions, I move to next slide. Okay, 3 minutes now, please. And if you don't understand, ask me why you don't understand, and you don't understand what, where. Okay, yeah, I will not explain to you line by line, sentence by sentence. No, you need to understand for yourself. You know, studying physics once is very relaxed, right? Yeah, not difficult. Okay. Any questions? No questions? Next slide. And 3 minutes. They require to calculate instantaneous acceleration. Okay, so for now we consider, so now they give us the function of Vx, right? The function of course, they also give us the curve of Vx and also the function of Vx. So it's up to you. You can use the function to calculate Ax. Okay, yeah. So we find the acceleration in the time interval t0, and the final time is 2 seconds. Okay, yeah. So for you, yeah, we just apply the formulas. We have Ax average, E delta V x over delta t. That's mean how Vxf minus Vxi over Tf minus Ti. Okay, yeah, and they give us this is the information of Ti and this is Tf. So if you get here 20. Okay, so you get 20 is minus 40 divided by 2. So you get minus 10 meters per second. Okay, yeah, it's easy. Or you just calculate here we have Vx, so we have Ax, A derivative of Vx with respect to times. Okay, so you get here is minus 10t. Okay, minus 10t. Okay, yeah, and we have for delta t. Delta t is what? Delta t. Minus 10t, right? Okay, so here we have here we have ax. This is instantaneous, right? Instantaneous is minus 10t. Okay. So for determine instantaneous acceleration at the time t of 2 seconds. Okay. So this is the slope. Okay. This is the slope of Vx. Yeah. This is slope of Vx. Okay. Yeah. And you don't have to calculate Ax, right? So Ax is minus 10t. Okay. Yeah. So we have TIs. If we say TIET, so TFE T plus delta T, right? Yeah. So now if we have TIET, you get AX is minus 10 times T. If TFE T I plus delta T, that means we have T plus delta T. So we can guess AX is what? AX is minus 10 T plus delta T. Okay, so we can get minus 10 T minus 10 delta T. Okay. And this is X is linear curve. Okay, this is slope. Okay, yeah. So we can guess Ax instantaneous is this one's minus one. You get minus 10 delta T, and delta T is 2, right? At the beginning, yeah, delta T is delta T is 2, so you get it's minus 20 meters per square second. Okay. This is another way, or you can use the formula. Okay, so we can calculate Vxf and Vxi. Okay, so Vxf is what? Because Ti is Et and TF is what? TF is T plus delta T. So we can calculate Vxf. Vxf is 4T minus 5T is Et plus delta T. So to square, you get this one. Okay? Yeah. So here is Vxf. How about Vxi is Vxie? 4t minus 5t squared. Okay, so you can calculate delta Vx. Okay, and then we calculate limit. You can get minus 10t. And t is what? T is 2. So you get also minus 20 meters per square second. Do you understand? Yeah. So it's up to you. Okay. Okay, is it clear? Yeah. Continue. Oh, finish. And here we have the summary of acceleration. Okay. The ratio of delta Vx over delta T is the rate of change of the velocity, or we say the slope of Vx. So the slope of Vx. The slope of Vx is Ax. Okay. So remember that the definition of acceleration is the rate of change of the velocity, or we say the slope of this Vx is Ax. Look, the slope of Vx is Ax. Okay. Now very easy, so just skip it. Skip it. Okay. Yeah. So we can find an acceleration graph from a velocity graph. Yes, of course. Here, this is Vx. It's Vx. So Vx is linear curve. So Ax is the slope of Vx, and of course Ix will be constant. And Vx is constant, Ix is 0. Okay, this is for the first quadrant, and the slope here for the last quadrant. So Ix is negative. Okay, very easy, I think. Right. Or you can read some description here during the initial segment. This initial segment of the motion, the slope is constant, so the acceleration is constant. Okay, because the acceleration is the slope of Vx. So here the constant velocity means zero slope on the velocity graph, and then you get zero acceleration. This is negative slope. Okay. Negative slope on the velocity graph means negative acceleration. Okay. So multiple choice questions. Okay, now do it. Okay, 1 minute. Try to get the answers. A particles have the velocity is v1. Okay, so v1 is going down. When it moves from point 1 to point 2, the acceleration is shown here. Okay, so the vector of acceleration is opposite to the vector of velocity, right? Opposite. So what's its velocity vector v2 when it moves away from point 2? That means what is vx like this, or sorry, v2 like this, or v2 like this. Easy, right? Very easy. Có đáp án rồi biết. Continue. Female first. So maybe if you get the correct answers, you get 1%. Wrong answers -1%. Okay, it will be more funny, right? Female? No? Female students, please. Don't be shy. Okay, how about you? Yeah. Bạn nữ đó, bạn nữ cạnh thằng áo đen đó. Tên gì? Nữ áo trắng em đó. Em tên gì? Giang. Your answer, please. Sorry. Pardon? B. Okay. Maybe yes, right? Other answers? No? Check. You know, because I also give you some hint. You know, we have A and B. They are opposite to each other. Okay, so that means after point 2, the magnitude of Vx will be decreased. Okay. So how about vector A is like this? How about vector A like this? Okay. Yeah, it will be A. Okay, because because A and A and V have the same direction. The same direction. So this is could be A. Okay. Okay. Continue. Next. This motion diagram shows a particle that is slowing down. This is X, right? This is X. And we stay here. We stay here, right? We stay here. So if we stay here, you can see delta x1 is higher than delta x2 because this is x, right? And delta x2 is higher than delta x3 and higher than delta x4. Okay. Yeah. Yeah. So and when we analyze Vx and Ix, I choose origin here. 0. This is times. This is Vx or Ix, right? So, oh, sorry. Time should be here, you know. So here is move to here. Okay. Yeah. This time is 0, and here time is positive, right? And positive. So that means I just move here, right? Move here. The origin to be here. To be here. Anyway, for the final exams, I will make sure that what is the direction of X, right? What is the origin? Otherwise, we have some confusion. Okay. Answers? Very easy, right? Just it depends on these origins, you know. So let me see the reference answers. Of course, if the position is positive, if position is positive, so that means we need to fix the origin here. And at the beginning, you get here is xi. Okay, xi. Yeah. So here you get position. And after some time, you get xf, and you get next one. Okay, so for positive position. Okay, but you can observe the direction of velocity. So velocity is negative. So that is the reason. So if we choose coordinate here, okay, here, you know. So that means at the beginning is xi here, right? And then xi1, always say x1, x2, blah 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 blah. So x is negative, right? X is negative, and the velocity is also negative. Okay, do you understand? So for the final exams, I will make sure where is the origins, where is the starting point we are considering. Okay, we are considering. Okay, yeah. Otherwise, confusion. Okay, just because some multiple choice. So I try to let you understand the theory. So some mistakes. Sorry. Okay. So look at this one. We consider the size of acceleration. Okay. We how the comparisons between this case and this case. Any questions? The last multiple choice questions. Yeah. Okay. Okay. We observe the direction. Here they already give us the direction v, vector v.
Should it be below if the velocity is negative? Should it be in the third and fourth quadrant, like below the x plane?
Sorry, I don't understand what you mean.
Ý con là con tưởng là mình sẽ là cái trục y thì cái đó nó muốn cho y của ông thì nó phải ở mà dưới OX hơn hay là
có thể là thầy sẽ làm rõ cái trục x này khác. X này có thể nó xem như là một cái direction, nó không phải trục x, một cái direction. Và nó tức là nó xem như là một cái direction, cho nên nếu mà ở đây nó là hướng, rồi nó đã ghi là hướng bên đây hoặc là hướng bên đây đây, hiểu không ạ? Cho nên cái thằng x này được hiểu là cái straight motion thì nó có thể là nó đi từ đây qua bên đây hoặc là đi từ bên đây qua bên đây. Cho nên chúng ta thấy là gì, nếu mà thầy gọi đây là góc tọa độ nằm đây nè, thì rõ ràng đây là điểm bắt đầu. Điểm bắt đầu nó đang ở trục dương nè, đang là trục x nè, hiểu không ạ? Hay hoặc là thầy ghi t, đây thầy ghi x cũng được luôn. Thì sau một khoảng thời gian thì chúng ta thấy là displacement đang giảm dần này. Nhưng mặc dù nó giảm dần nhưng nó vẫn thuộc các phần tử thứ nhất, cho nên nó là positive, hiểu không ạ? Hiểu đó không? Nhưng mà nếu thầy chọn góc tọa độ nằm đây là khác. Nếu chọn góc tọa độ đây thì ban đầu nó là gì? Positive. Sau một khoảng thời gian nó là negative, hiểu gì đó không? Cho nên là thầy mới nói là cho final exam thì sẽ làm rõ đâu là trục nào, không thôi là mấy đứa sẽ bị confused. Okay, yeah. And don't worry, just understand how to determine the direction of position and the direction of velocity. Okay, you can get the correct answers. Okay. Yeah. Is it clear for you? Okay. Yeah. So don't worry, for the final exams, I will give you what is the meaning of x-axis, what is the meaning of y-axis. So here, for the final exams, you should expect to me here is t, here is x, and this one is t, and this one is vx, right? Vx. So if here I say here is t1, here is t2, here is t3, here is t4, here is t5, okay? So t1, you can guess x1, right? t2, you can guess x2. You understand? And T3, you can guess X3, and of course, you know X is positive. And if we consider the origin here, if the origin here, yeah, we can guess X always positive. Okay? Yeah. And then you can get Vx also. Okay. Yeah. Or we can say velocity is a negative because the displacement is decreased gradually. Okay. So for here, observe this one. Here is V, here is A. You know, V. Yeah, you stay here. Yeah. So here you stay here. And then when you observe, you know, Vx reduce gradually. Yeah. So why Vx reduce? gradually because A is opposite to the direction of V. Okay, so V accelerated is like this. Okay. Yes. But if you stay here, what will happen if we stay here? Like this, right? Because Vx now, if here is origins, and here Vx is somewhere. Yes. Okay. So for negative, so you get this one. But anyways, you just follow here because follow the arrow of the arrow direction. Arrow here. Okay. How about this one? Not here. Should be here because t is t right. So t is negative. So must be what? Must be here, right? Yeah. Sorry. My stupid. Sorry. Do you understand? Yes, because you stay here, so it is positive and negative. So here you get negative velocity to here. How about this one? You stay here. Okay, and then we here is 0, here is positive because we start at the time ti 0 and after some time, so tf must be positive. Okay, so t is 0 to positive. Okay, and what else? Velocity increase gradually because v and a. Okay, yeah. It's wrong, right? It's wrong because if t is positive, v should be what? We also consider the direction, right? Consider direction. So if we have direction, here is positive direction, here is negative direction. Yeah. Maybe we have another explanation to clearly understand. So first of all, we can make sure the magnitude of v must be increased, right? Because the direction of the velocities and the direction of accelerations are the same, right? Yeah. Now, for the second one, we need to determine velocity is positive or negative. Okay. So follow this one, you cannot stay here, right? We cannot stay here. We need to stay here. Yeah. And this is t0, t0. Okay, and the position will be negative, right? The position is negative. That's correct. I think no, right? I think no. Because if the position is negative, must be origins, right? Missing origins. Yeah, depends. So don't worry for these exams. I will make sure where is the direction of the position, where the direction of velocities and anyway, we just compare the meaning of this line. That means we just compare the velocities of v and the velocity of a to make sure v is increasing gradually or v is decreasing gradually. Okay. Multiple choice questions. Okay. So this motion diagram show a particle that is slowing down. Okay, that means this is the starting point. It is starting point. Okay, after some times, displacement decrease. So the size of the acceleration ax. Okay. 1 minute. So we can use A is delta V x over delta t for easy, right? For easy. So here is Ti, and you get Xi. Here is Tf, and you get Xf. Okay. Yeah. Or you can see this is delta V, right? Delta Vx. So delta Vx reduced, so that means delta V is negative. Okay. And delta t, you stay here, so delta t is positive. So the answer, it's been negative. Why is it positive? Let me check. Or if here we know directly the position vector, that will be okay, right? Position vectors. Or if you stay here, you think about the origins, not here, and you get the vector of position like this. Okay, so R is positive. So now R becomes reference axis. R becomes the reference axis, and we compare vector V and vector A with the reference axis. Is it suitable? Okay. So now I unify. Okay. So for the question like this, I will give you the vector R, position vectors. This is the key point. If we know where is vector R, you can determine the direction of V and A. Okay? Yeah. Okay. Sorry. Alo. Tòa BE7 là được. Okay. So anyways, I will unify the information for you. So for the final exams, I will give you the direction of the position, and then for the direction of position, and then here is Ti, you get Xi, and after some time you get vector R is also positive position. Okay, so vector V will be negative and vector A will be positive direction. Okay, it's easy. It will be easier. Okay, then the same, now what time is it? Okay, just one more questions and then we stop. Okay. We have these velocities. Okay. And we don't know the way the starting point. So if we follow this one, here is starting point, right? Here should be starting point. Okay. Yeah, starting point. And starting point. Okay. So for his rise at 20 mile per hour, I see a stop sign and actually come to a complete stop in 4 seconds. And then in 6 seconds, return a speed of 15 miles per hour. That means his speed is decreased. Okay. Oh, where is stop sign? Here. Is stop sign, right? Stop sign. So we can choose this one is the time. This is X is Y, right? This stop sign. Yeah. Blah blah blah. Okay. Of course, if he would like to stop, the acceleration must be opposite to velocity direction, right? If he would like to stop. Okay. So if this one, can he stop? No, of course, because so we delete this one. So we eliminate this one. We eliminate this one. Do you agree with me? So now, look, the acceleration magnitude will be the same. Okay, so so up to now, at the left side, this is the right side, this is the left side. So B and C, that's okay. Now we consider this one and this one. Okay, so when he gets stopped, he returned. Okay, to a speed of 15 miles per hour. That means after some times, okay, this speed will be increased gradually, but this also increase, this also increase. Oh, but this one is 20, right? This one is 15, smaller than this bit. So, B. Okay, so you can delete this one, and the answer will be B. Okay, this one is more clear, right? Because we know where a position vectors. Because you already stay here, Yeah, so we know the position vector, the starting point. But for this one, a little bit confusion. Okay, don't worry, I will make clear for the final exams. Okay, so yeah, what times maybe this one, different starting point. Okay, different starting point. So these four motion diagrams show the motion of particle along x-axis. Okay, so which motion diagram correspond to a positive acceleration and which motion diagram corresponding to a negative acceleration? Easy, right? So that means every A, B, C, D, you need to choose one or two, one or two, one or two, one or two. This one distance increase, right? Distance increase, so that means increasing acceleration, right? And you also stay here, so here should be one and so on, right? So on. One or positive, okay? Two be negative, okay? Continue. Here, after some time, you start here, and after some time, you get stopped. So that means distance will be decreased. That means acceleration will be negative, okay? Two. Now you start here, okay? And after some times, you get stop, okay? So that means positive. Okay, positive. Positive with what? Positive with position vectors. Okay, you need to compare with position vector. Okay, yeah. Right? Yeah. Position vectors. And now it's the position vectors here. And I should be follow the same with the direction of R. So R is negative, so A is negative. So the key point is you need to know where is the position vector first for references. Okay, stop. And yeah, we have many. Okay. So next week we continue to discuss some multiple choice question. Now we stop at slide 29.
Và với tiếng Anh em làm Hàn Quốc thì cái bài này